Um, oh, excellent. Somebody is recording. Very good. Um, let's start. Hello, good afternoon. My name is Michael Haberle. I'm supposed to give a talk on meteorology and forecasts, which I'm totally unqualified for because um, I'm basically an MBA with some electronics background. I've never learned this, so all this is from my practical experience and through patient mentoring by Heidi Schmidt, who has been my mentor over many years now. So I picked up a little bit here and there. I have a private pilot license and about 900 ballooning hours, about 20 or 30 Alps crossings. Um, Moderate experience. I've found over the years, as I personally come from the internet industry, I've been looking for um, useful IT support for my hobby. And one of which I've stumbled upon is the Windy application by the Czech company Windy, which I'm going to talk about here to make most effective use of it. Um, just to clarify the relation between Windy and myself, I'm just a user. I have contributed a little bit to the software, the occasional plugin, and if you look at the radio sound layer in Windy, that is something which I've written together with a colleague, and we've handed that over to Windy. And I've integrated it so it's now part of the standard service offering. Okay, let me go through it. I'll have to talk a little bit about the philosophy and the background of things. Another topic which we need to cover is absolutely minimal introduction to forecast models. That's something which took me a while to grasp. And I'm just going to be focusing on the European ones, although Windy has worldwide coverage, different models in different regions. But we'll need to talk a little bit of the background because that is relevant for flight preparation. We'll go through the user interface. Windy has a ton of features, and it's actually quite complex. And it has a ton of views, like 50 or 60 different layers, which can be studied, observations, forecasts, and the like. Many of those which are not relevant for aviation. So we'll exercise a little bit getting organized and making most of the user interface. And then let's go through the standard steps, looking at forecast for a particular location, looking at the various variables like wind, gusts, temperature, humidity, clouds, and so forth. In the more advanced part, we'll look at using what's called plugins. Windy has been quite innovative by enabling something unique, namely users can add features to the weather application by writing their own plugins. That was a real innovation. No other weather app I know of has that, and it has spurred quite some creativity. I'm going to cover three of those. One of them is the trajectory forecast plugin, which is quite relevant for the hot air ballooning or ballooning in general. So we'll look at those. We look at radar and radio sound views and sounding, so the vertical dimension of the atmosphere. And a third plugin, which is quite interesting in the Alps region, it's called Upper Winds, but it really is a phone forecast plugin for phone, but also other winds typical in the Alpine region, like Burja, Mistral, Ora, and Pela, and the like. Okay, so let's jump into it. I hope I'm sharing the right screen. Yes, that should be it. Just to compare that with a standard application like weather.com or the like, what they typically do, they take some mystery data, they throw in some vendor value, which is not quite well defined, kind of a secret sauce. They turn the crank on a meat grinder, and out comes a forecast, and that says, okay, that's going to be the weather at that very location. Now, you can believe that or not. It turns out the mystery data is mostly the forecast from the US weather model, global forecasting system, because that's the oldest and that's been available for free for the longest time. It is also one of the worst having available. So results are mixed. You can believe that or not. Some of you might have dealt with a different approach to viewing geographical data, and that's called a GIS system, or Geographic Information System. Windy takes that approach to viewing weather variables. Let's go through it. What's the category of data you can see? First, actual measurements like wind gusts, temperature, cloud, precipitation, radar and satellite images are observation data. So that's anchored in reality. Then we have the forecast data, which comes from forecast models, and we'll touch upon those in a minute. Then there's a couple of data integrations, which not directly have meteorological significance, but they're very useful to have there. For instance, the Windy has an excellent integration of a lot of, literally hundreds or thousands of webcams. If you're not sure, for instance, if there's fog or cloud cover or the like, the webcam can be a very helpful feature, which is typically not available in other meteorological forecast applications. And the category of user extensions plugins will come later to that. So that's basically the stack of data which is available for viewing: current data, forecast models, data integration, and whatever we add ourselves to that. Now, to make sense of that, we need a couple of more detailed parameters, namely for which location, for which time. Sometimes for some values like wind, altitude is relevant. So you'll have to pick one of these parameters on the left and data sources. You mix it with location, time, and possibly altitude, and what you get is an aspect view. So the whole thing is a data viewer. It's not a synoptic forecast like here's a cold front coming, here's a warm front coming, and the like. It doesn't do that. It doesn't summarize the weather for you in a synoptic fashion. It only gives you a data view, but a very detailed one over many different variables. So anybody who has worked with geographic applications will recognize the idea behind that. That is the typical approach in a geographic information system. Fine. So let's talk about forecasts, forecast models a little bit. Now, what are those? Forecast models try to predict meteorological conditions based on a starting point, which is mostly defined by measurements, and try to look into the future based on that. That's a very computationally intensive task, but that's the overall approach. Now, there's a ton of different forecast models, but it helps to distinguish a little bit how they differ. First difference, coverage. There are there are a couple of global models. There are regional models which say cover like Europe, and sometimes there are even smaller ones. Excuse me. So the coverage is one distinguishing factor. The second one, how a weather model doesn't compute a continuous coverage of the Earth's surface with forecasted values. Actually, it divides up the coverage region into a grid, yeah, and it computes the forecasts for each grid point. One key attribute of the forecast model is the density of that grid, okay? We'll come to later to having a look in a mountainous region, how the grid resolution actually heavily impacts the quality of the forecast, which can be had from a particular model. So coverage, grid resolution. If we look at my little table here to the side, you'll find these grid distances anywhere between 1 to 2 and about 30 kilometers. Yeah, the 1 to 2 kilometers class, that's the higher resolution models, and the large coverage models, like with the global coverage, tend to have a lower resolution, so higher distancing grid points. Now, what happens if you are between grid points? What does the weather app tell you? Well, it just interpolates between the neighbored grid points, mostly the 4 neighboring grid points, the one which you're in. So these are not based on actual computation, but on the values the neighboring grid points give you. They clearly vary in orographic detail. For instance, do they take into account convective activity, or is it just based on altitude, or what's called hydrostatic models? Well, I'm sorry, I blew it here. Let me go back. One key attribute is the look-ahead range. How many hours or days does a weather model look into the future? And we'll see in a minute how that correlates with grid point resolution. Then one attribute which cannot be directly derived from these mathematical parameters like grid resolution or look-ahead days is, what is the focus of the model? What is being tried to achieve? Forecast models can have different focus. For instance, short-term models which only look into 1, 2 days or 2 days in the ahead, medium range forecasts and long range forecasts. The longest range you get with today's forecast models is about 2 weeks. Yeah. For instance, if you look at the ECMWF, European something letter soup, I have no idea, but the M in here stands for medium range being anywhere from three to 7 days. Yeah. So this model focuses on a medium range forecast, whereas the latter two, Icon D2 and our own, are very short term. They have only 2 days of look ahead, and they're short term focused. Yeah. You would think, let's say, some aviation bureaucracy like Control or so, if they predict takeoff conditions for various locations, they would use a short-term model. Nope, this is not the case. Control uses the ECMWF for short-term forecast, which is basically nonsense, and it gives you mostly in terms of wind way too high ground wind forecasts, but that's just the way it is. So it does help to supplement these official forecasts and briefings with your own information if you know about the deficits. So summarize: coverage, resolution, the detail, convective or hydrostatic only, look ahead range anywhere from 2 to 14 days. And is this a short-term model, medium range, or trying to do a long-term forecast? So that is basically the set of attributes of weather models, which you should keep in mind, because Windy has a ton of weather models available, and they show up in the menu only as a soup of abbreviations. And initially, I couldn't make a lot of sense of this, what I would prefer for which task. Yeah? But we'll come to that in the next slide or so. But that's probably the most relevant models which we will talk about. Actually, the Icon model, which we have 3 lines here, that's what's called a nest. A nest is a set of models which has inserts of higher resolution models. So the Icon model per se has a global resolution, and what Deutsche Wetterdienst, which produces Icon, does is they do a nest or a cutout for the European Union with a higher resolution. You see here in the grid about twice the resolution for the whole EU region, including North Africa and up to the Arctic. And out of that, again, they do an even smaller cutout, the Icon D2 model, which has yet another factor of 3 of higher accuracy or resolution, and that just covers Central Europe. Fortunately, we, Austria and Slovenia, are all covered by Icon D2. There's a very good one which is produced by Météo France called Arome. Unfortunately, this covers only Western Europe. So in terms of, in case of Austria, the eastern boundary of the Arome forecast ends anywhere around Salzburg. Coverage only west of Salzburg. Okay, so that's the overview of forecast models and their attributes. Now, you might have noticed that the large look-ahead models, global coverage models, all have very loose grid meshes, whereas the short-term models have very fine grid meshes. Why is that? Why cannot we have a higher resolution global model? The answer to that is simply computational complexity and hence computing cost. If you would say compare Arome and GFS, so they differ in about a factor of 15 in terms of grid resolution. Now the grid is a quadratic affair, so we're talking about a factor of about 1 to 200, what the same area costs to cover in Arome. versus GFS. And that's only due to the resolution of the grid. So, and that is the reason why the higher resolution models are short term, and the low resolution models tend to be longer term. It's just about the limits of the technology which we can forecast with. To give you an idea how grid resolution impacts visibility, I've done a little animation video here. Let me stop that and go back. What you see here is the western part of Austria, yeah? And I've overlaid the grids of several, excuse me, of several models here, starting with a GFS model and going onwards towards the more higher resolution models. I chose Western Austria because that's a quite complex topography, mountains, narrow valleys, and the like. One particular valley you could keep an eye on is the Inn Valley, which passes through Innsbruck here in a mostly west-east fashion here. If you look at the rectangles here, the Inn Valley is maybe 10 kilometers wide. The boxes are 22 kilometers wide in the case of GFS. That model has no idea of the Inn Valley from a resolution perspective. It might have due to altitude, but not from a basic resolution. Now let's run this so you get an idea. So that's for GFS. ECMWF has higher resolution. That's ICON, the ICON EU nest, and that's the ICON E2 and the AROM models. You notice that suddenly the valleys appear, so the higher resolution models get a more granular view of the topography. So the more complex the topography, the more important is to use high resolution models, because low resolution models like let's go back here, GFS don't even have an idea there's a valley here, whereas AROM shows you quite well the Inn Valley. Yeah. So that's to get and convey the idea of what a model actually sees. Now, the next slide is basically my personal preference. That's not grounded in meteorological know-how. I don't have any of that, except experience and some mentoring. So this is highly subjective. It's my gut feeling. It's mostly EU-centric. You get different weather models in other parts of the world. I haven't used any of those. And I've also focused on the models which are supported by Windy. Yeah, so that explains the selection. But I've tried to convey my own gut feeling here in terms of forecast time spans and which model I would use. But it's always the same. If you do something short term, go for a high resolution forecast model like ICON D2 if you can get it, if your region is covered. Yeah, like AROM if you can get it and compare it with ICON D2. Those are most valuable for short term. I tend to trust ECMWF, in particular wind-wise, only 3 to 4 days out to 7 days. That's when it's most relevant. And later on, ECMWF and GFS are the only ones available for 7 day plus. Sorry. Okay, so that's about weather models. I want to conclude with the theoretical introduction and philosophical introduction, and turn to the practical use of Windy now. And I'm going to share a different screen for that purpose. The windy application appears in several shapes and forms. The most common to use is as a mobile application on a mobile or a tablet, but it is also available as a website. And I'm mentioning this because they are somewhat different. The website version, the one which you look into a browser, has certain capabilities which the mobile versions do not have. In particular, the plugin capability. You cannot use the plugins in the mobile applications. You can do that, however, in the web version. So, meaning if you're serious, use the website with a Chrome browser or similar on a desktop if you can. One of the reasons why I recommend that is there's a lot of information on this windy screen, and it's getting pretty crowded. So on a little mouse cinema type display of a mobile handset, it gets a little bit harsh to discern the details here. So we'll go through the basic settings, then the hamburger menu. We choose preferred layers like the quick menu points of interest. We'll look at selecting layers and making them permanent in our view of the world, setting favorite locations. We'll look at different weather models and layers, work with the time axis and what's called the location picker. And we'll look at 3 examples for the plugins. So that's the plan for the rest of the talk. We're about 25 minutes in, and I think we're in good time. So before I switch to the live version, I've prepared a slide to clarify terminology. That's a screenshot of the Windy web version. And let me go through the key user interface elements. Let me erase those annotations. Yeah, okay, I accidentally draw something here. The first window at the top left, that's pretty clear. You can enter a location name here, and it will look up the coordinates and zoom the coordinates to that location. You have also the ability to add a location as a favorite with a heart symbol. I somehow missed how to do that. The key user element here on the right side is what's called the hamburger menu. The red circle with the 3 horizontal white stripes, that gets you to the settings view and more detailed view of the application. And that's below the hamburger menu, you have what's called the quick menu in Windy speak. That is basically a selection of layers. You remember we talked about this in the introduction. For instance, I'll have here cloud layers, medium clouds, high clouds, visibility. So some of those are forecasts and some of those are observation. For instance, satellite view is an observation, weather radar is an observation, but the rest are pretty much the rest of it are forecasts. Yeah? So both of these data elements show up here. This is basically my summer setting, if you will. You won't find snowfall or the like. I'll change the view a little bit for winter because, for instance, thermal views are not relevant in winter. Below the quick menu, you find a slider with an aircraft symbol here. That's called the altitude picker, and it is relevant only for the layers which are sensitive to an altitude parameter. That's basically only the wind layer, okay? So you can look at the wind forecast in different altitudes by pushing this slider over here, okay? What else? Below that, well, the fourth bar from the bar below that, the plus and minus is basically the zoom in, zoom out function. An interesting one is the model status, and we'll have a look at that. If you're making a decision about flying or not, make sure you have looked at the model status, because it tells you when that particular data which you're looking at was actually generated. Just to make sure you don't see an old version of the data which might not be applicable. And zoom, okay. So below that we have the points of interest bar, the heart that shows your favorite locations. With wind forecast, measured winds, measured temperature. A very useful one, which we'll look at, is the airports view, because that gives you the metas and tafs for the airports, but also the airspace view, which can be very convenient. The webcam view, which I talked about, and the radio sound view that shows the radio sound essence. And the last one below that is the model selection tab here. This enables you to select one of different models, and we'll go through the example. You'll see the impact there. So at the bottom here, you have the units layer, the units bar. If you click, that shows the unit for the currently selected variable, for instance, wind. Yeah, wind is the currently selected layer. You can see that at the dark shading of the word wind here. And it shows the unit here and the color coding of the speeds. If you click at the kilometer symbol, you can click through different choices of units like Beaufort and knots and what the like. So that's the units. Now we have location, we have models, we have the choice of variables. Now let's look at time. At the bottom layer of the window, we have what's called the time selector. Yeah, and that selects the point in time for which the forecast is being looked at. So by sliding this time selector, you can view at different points of time of the data within the range of that particular forecast model, of course. And you can actually do something like an animation, which is the play button in the left bottom here, which slowly walks you through the timeline as it progresses. Okay. We haven't covered location choice yet, only the plus and minus buttons here. Now, if you click on the map somewhere, it shows it's a symbol like that. It's called the location picker. So it's basically the point and a short forecast for that particular location based on the layer which you've selected here. So in that case, there would be 8 kilometers per hour wind at about 50 degrees direction. And it also gives you the ground altitude. So it has a elevation model included. Important one is that amber drop down here to the right. If you click that, you get a more complete forecast for that location. Okay. So you see that's a ton of symbols and meanings in this screen, which is why one of the reasons why I'm suggesting to use the desktop model, desktop view if you can get it. So let's progress. I'm going now to switch to the windy view. Let me see on how to the actual view of the application. let me see how I do this. I'm not very good at choosing this. Here is the stop share. And how am I sharing this? Okay. In theory, you should have two windy screens now. Can you confirm that?
Yes.
Oh, okay. The left one is the web version. Yeah. That's what you get by looking at the website windy.com. Okay. And the right one is a screencast from my iPhone, which I have lying here beside me. So that's the web version, and that's the mobile version, if you will. Let's go through this one by one. We've talked about the hamburger menu and our list of layers here. Yeah. Let me click that here, and you see it pops up a drill down window with a choice of layers which we can add to our list of preferred layers. I have wind gusts, thermals, fog, blah, 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 so forth. What we could add, for instance, snow taps or precipitation type, that might be interesting for summer. Let me add that to the view. What I do is I click on this, I drag it over here, if it works. Jesus. I need to click here the Arrange Layers button. And now I can drag this over here, for instance, to this position. And now I'm done. So I've added the precipitation type layer to my view. The same thing is I can remove that by pressing the garbage can symbol, and then I'm done. For instance, layers which I'm not interested in is the hurricane tracker. You can do that, but this is pointless for me because we're not in a hurricane region. But you see, if we scroll here, so that's something like 25 or 30 different data aspects. So sulfur oxide, carbon monoxide, dust, and so forth. So that's how you populate your layer of the variables which you're interested in. Let's do an example now for wind. I'm selecting the wind layer, which we talked about. And by scrolling in and out, I can select the map region. Now let's zoom in on Slovenia. Let's say Maribor here. Okay. If you look at the bottom here, you see this is by the ECMWF forecast model. And to the right here, I can display all the ones which are applicable here. Let's, for the fun of it, choose a very high resolution model as a contrast. We don't see anything. Why is this? Well, it's because of the coverage of the Aron model, which basically ends right through the Austrian Alps. So it's just West European coverage. But let's drill down here for, let's say, Villach. You see some valley detail here. Sorry, that was a little bit too nervous. You see quite different wind forecasts for some of the alpine valleys. Now, for the heck of it, let's jump back to the global model and see what changes visually. See something? zero. This model doesn't have a clue of wind in the valleys. Yeah. Whereas Icon does, as does the Icon D2 model. Yeah, that has similar resolution. That shows you the wind detail in the valleys quite well. Same goes for other aspects, like for instance, for us, very important is the wind gusts view for takeoff and landing. Let's look for a moment at GFS. Well, okay. There's no such thing as detail here, right? Whereas the Icon Rome give you pretty fine detail of the valleys. For the heck of it, let's look at this location and use the location picker. So I clicked here, and you see that little flag came up here and says, we'll have wind gusts up to 38 kilometers an hour here. And if I move that around, so that's obviously a protected part of a valley, or this one down here near in the Boinske Jezero. So it's almost no wind here. So obviously the lake here has an impact. I didn't know that, but Western Slovenia is actually covered by Arom. Again, let's switch to a low resolution model. Well, nada again. So I think that drives home the point pretty well on why you need to be aware of what the model does, what resolution it has, and what data it gives you. Let me click on Icon D2, and just for the because I talked about it, the little eye in the white circle here shows you the validity information of that model. We click that now and have a look, and a pop-up appears which says, where does this model come from? What model is it? And in particular, when was it last updated? So this is a really recent model run. The data is only 17 minutes old, and a description of the variable, which we're not interested in. So let's close this. But just to make sure, you want to have a look at that, just to make sure it's not old data. Because if you let the windy website sit overnight and you look at the wind next morning, you might have all the information on the screen. So always do a reload of the website and look at the validity information. Okay, so we covered on viewing one particular variable over different weather models. What we haven't done yet is look at the timeline. You see, I'm currently using the Icon D2 model here. Let's go through the zoom out a little bit. And at the bottom here, the time selector, you see 3 days, Friday, Saturday, Sunday. So that is the look-ahead range of the Icon model. If we go click that and change to GFS, let's try this. You saw the timeline changed. So it looks out into like Friday 23rd. So that's the longer forecast range of the GFS model. ECMWF, same range. And let's go back to Icon D2. So we get the high resolution model of the Woche NRC here, okay? What we can do with the time parameter, you see, it says here current time, so Friday the 9th, 1800 hours. Times in windy are always local time, they're not UTC, warning, okay? You can change that, but by default, it's local time. So you need to correct for UTC, okay? Look at what I can do here. I scrub through the timeline, and you see how the forecast, the coloring of the map changes. So, for instance, tomorrow noon, we have a much less wind than actually now, like in the Julian Alps and Gas, in the Gas, it's actually quite windy. Let's scroll this up a little bit. Well, you see the wind here? That looks a little bit like Borea. And I'm clicking on a little button here called particle animation. You see what happens? It shows a wind animation by moving particles. And in fact, this is a slight Borea situation. We'll come back later. Well, slight. 18 kilometers per 38 kilometers isn't, well, that's the gust. Okay, let's go back to the wind. 31, 38. Okay, but if we go here to the Bipower Valley, well, okay, everybody who's driven that highway knows what that means. So that's quite strong buoy there. But that's really for today. We'll have a peak at somewhere like tonight. And tomorrow morning, the whole thing should subside. Yeah? I'm doing this now by manually scrubbing through the timeline, but you can do something like the following. We scroll back to the start and click the play button here. And you see now that the timeline progresses slowly through the forecasts. You see, so the winds become less and less. So it animates by itself. So that's the two options. You can move the time selector manually with the mouse, or you can have it run with a play button. Anyway, so that was the arranging the preferred layers and looking at the layer. I'll do one more detail drilling, and I'll switch the view for a minute. You remembered the hamburger menu. Let me switch back for a second because that's not a very good view. Share. Let's see this. We should see the windy map here, yeah? Okay, we looked at the hamburger menu, and we looked only at this upper part here of the variables we can look at. It's important to be able to scroll down and explore the bottom part here. There's actually some documentation at the bottom. And this list in the dark blue box here gives you options on how you populate this bar down here, the third one from the bottom. In my case, that's reported wind, the airports, the webcams, the radio zones, and just an empty map if I want this detail going away. For different purposes, you can have other aspects being in this quick selector, like active fires or radiation. I'm not interested in that. Okay, so we'll go through that. In particularly, we'll go through the airports view because that's an interesting one. You see, it pops up a submenu here. And it gives you two options with buttons here. VFR, airspace map, and heliports. So smaller airports, if you will. And I've selected the airport view now. And you see If we zoom in, we get, oops, the windy map switches to a higher detail map if we zoom in too much. But you see, it's now been overlaid by the VFR map, and you can, since airspaces are typically stacked on top of each other, one location might have several applicable airspaces, and you can cycle through those by clicking those two buttons. Now let's go, for instance, to Maribor. We're here. I assume we'll have several airspaces. Well, yes, the TMA, I think, is that no, is not. Anyway, you get the idea. So it's TMA Maribor and the control zone of Maribor approach. So that's how you mix in airspace information if you want to use that. We did that by going down here and clicking the airspace map button. Yeah, I'll do that away. I'll leave that, but I'll switch to a different layer. For instance, high clouds. Oh, it still shows the airspace map because I have selected the airport icon, the airplane icon down here. If I click on the empty map button, it should go away, and it doesn't. Anyway, we'll do it this way. Just deselect pin to home page. Maybe that did it. No, that didn't do it as well. So once more, airports, click away the detail information, and the airspace is gone. Okay. So that is airports and airspaces. Let's click on one airport. So that gives you the detail view, which is quite handy. It gives you the runway information, the applicable METARs, any webcams in the vicinity, and any applicable NOTAMs. That might take a while. Yeah, that's the list of applicable NOTAMs. So that's quite handy to have. You see here green, it's all VFR. Let's zoom out a little bit. And you see lots of green dots here. This means most of Europe is VFR at this point in time. But we have one here, Crotone. Let's look at this one. This one's red. Let's click on it. Well, it's in minimum VFR, so it is in not as great meteorological conditions. Okay, so the color of the airport gives us an indication what the status is, if it's VFR, IFR, or in between. Yeah, limited IFR. Yeah, same thing. So the zooming out, the color gives you an indication what the meteorological conditions are for the airports. So this was the airport view. We'll proceed to the webcam view before we return to the other data layers. You see I clicked on it on the webcam view. Now let's go in and zoom in a little bit. Let's see, Maribor, Steigert, Leibniz. That should be about Maribor. If you click on, yeah, that is. You click on the small preview window. It gives you a larger resolution. You can actually switch it to full screen if you want to. And the nice part is you can scroll through a history and actually play that history. So that gives you the last 24 hours. We'll stop that for now and go back so that gives you the view. That is very handy to have if you're not sure, for instance, if a valley is fogged in or not. Just look at the webcam view, yeah, like here. So that's the last 24 hours, the recent views, and the pictures below are the nearby webcams, so you can choose those. So that was the webcam view. I leave that again by clicking on empty map. For some reason, I must have removed airports. Well, I did. Yeah, we're back, but without the airspace view now. Okay. We did the airports. The last one, because I'm proud of it, is the radio sound view. This gives you the locations where there were recent radio sound ascents. In our region, that would be Ljubljana, I think. There should be one from Ljubljana. Yeah, here it is. This gives you the last radio sound measurement from Ljubljana, and the temp diagram. You see the temperature, humidity, wind speed and direction to the right. And we can actually switch that to full screen for a more detailed view, for instance, for a briefing. That's very handy. You see on the vertical axis, this goes up to 43 kilometers, which is quite high. Typically, we'd be interested in the lower layers of the atmosphere. So what you can do is you can zoom in on the lower layers. Now that goes up to, oh, sorry, I talked about the wind speed and not altitude. This view goes now up to 6,000 meters. So that's pretty much that's already IFR territory. If you go into the lower, this is up to 3,000 meters. Yeah? And you can, for those who had some practice in analyzing temp diagrams, this enables you to estimate the potential, the cape potential. Here, there's some in the middle range. There's some minimal cape, but there's convective blocking below. But I'm not going to cover that. That's beyond my pay grade. If you go through the altitudes here, scroll up and down with the mouse, you get temperature and dew point. So here we have -4, -5. At this point, we have 1 degree spread, which is not much. So likely there will be, we're in the clouds. -6, -4 should be out of the clouds, and it's clear up here. So we have 5 degrees spread here. On the left, it shows you the pressure and the altitude. And the right gives you the measurement, the interpolated measurements of the wind speeds. So in 3,900 meters, we have westerly wind with 25 kilometers per hour. I released the full screen view. You can look at a nearby radio sounds down here. For instance, one which is important for us balloonists is the Udine, and maybe Rome. Udine, Innsbruck is important. So that's an observation view. That's how you look at radio sound data. Now, what for the vertical sounding for when you don't have a radio sound as a nearby? Well, actually, you can do that for any location. For instance, let's do one, but it's going to be forecast based. So let's do it. Let's do one for Maribor. I click on the, I just right clicked on this little flag here, and you get a drop down here. It tells you the coordinates, the altitude, the weather picker, blah, blah, blah. You can do distance measurements. We don't go into that detail. The one I'm interested in is sounding, okay? Now this gives you a temp forecast, a vertical forecast based on the current weather model, okay? So if we change the weather model here, you see that also the forecast changes, okay? The sounding forecast. Sometimes they take a little bit. Yes, okay. So these are forecasted temps or vertical views of the atmosphere. You see here on the left shaded the likely cloud layers based on the spread between temperature and dew point. Okay, so that was radiosondes and vertical profiles. Let me just hop through a typical balloon flight planning view of things. Well, first, the one, of course, is what are the ground winds? So to do so, we'll look at a high resolution model, let's say for tomorrow morning, 7, okay? We'd be looking at doing that for the heck of it, in a Maribor basin, okay? So that is the mean wind. Looks doable at 3 kilometers per hour. Let's look at wind gusts. Well, it looks still okay. That's for 7 o'clock in the morning. Now let's do a 2-hour flight and see how the landing conditions are. Like at 9. Well, not much more. So from a wind perspective, tomorrow morning looks doable, okay? So that was wind and wind gusts. There's a very useful view, namely comparing the wind of several models. Let me click on the forecast view. Just let me repeat that because I was quick here. I clicked on a map, I got the location picker. I clicked on the forecast for location, and now I get the timeline for the currently chosen model, which is ECMWF, okay? And you see down here, you have choices like basic, wave and tide, that's for Paul, wind, meteogram, and airgram. For now, we'll focus on wind. So I click on wind. And what you see here is a table. The lines are by applicable model for that particular location. And for the location, also the wind barbs are drawn. So you see all the models actually agree this is going to be northeast or northeast wind. And the table here gives you 2 values per model, namely the average wind and the wind gusts. And that is very useful to have because let's look at tomorrow for morning, which we took as an example. There's no model which has average wind above 10 kilometers an hour, okay? So from a wind perspective, this looks good for a takeoff. And actually we looked at landing. If we look at takeoff at 7, you see the wind actually, the wind forecasts differ, and they are excuse me, somewhat less. That is quite typical when comparing several forecasts. If the winds are very low, very small, then the models differ a lot. If there's strong wind, they tend to agree more. Okay, so that was the wind forecast for tomorrow, Maribor. We did the gusts. That also looked reasonable. 13, that's survivable. Let's look at the other variables like fog. Do we have any fog? Well, not really. Okay. Let's click a higher resolution model. No fog forecast for tomorrow. Let's go back in time. If there's one which is left over from the night. Also no fog forecast. Let's look at the visibility. You see that is color coded. The visibility is quite good tomorrow. It's 74 kilometers, and that's the icon model. So this has a very high chance of being true. Let's look at the cloud layer. Okay, what do we have? Well, overall occlusion of 53%. Now, Windy gives us three different layers, namely low clouds, medium clouds, and high clouds. Low clouds is everything below. Low clouds is everything below 2,000 meters. Medium is 2,000 to 7,000, and high clouds is above 7,000. So we have no high clouds. We have a bit of medium and a bit more of low clouds, but not dramatic. 43% is reasonable visibility. We can look at the lower level of the clouds. It says it's not available for that location. It only has select availability, but the cloud base must be around 2,000 meters. Let's see what precipitation has to say. That's relevant for us. Let's scrub through the timeline here. You see in the Western Austria, in Switzerland, Upper Italy, Lombardy, will have some rain, but it subsides during the day. It comes back in the evening. Sunday, there's more chance. But in the window relevant for us, we looked at Saturday morning. Let's let it run here for a couple of hours. 6, 7, 8, 9, 10. That covers the balloon flight. So it's no precipitation near Maribor according to the Icon D2 model. Sorry, I accidentally clicked wind well, so let me click it away. So what else do we have? Interesting for ballooning is the thermals layer. Okay. Let me go back to the takeoff time, like 5 or 6. Like this is for 7, that's for 6. Okay, and let's zoom in to Maribor once more. It's Leonard. Okay, here we are. Let's have this run. I click on the play button, and we see a first thermal appearing a slight thermal at 7 already. At 8, there's significant thermal activity already. Yeah. So we click on this. This gives you I think the upper level of the thermal, the thermal tops of the thermals. Yeah. How far do the thermals reach up? Yeah? So this is a good forecast to have for ballooning when they were doing it to be back on the ground. So 8 probably is a good time. Anywhere between 7 and 8 would be a good time to be back on the ground. Okay, we looked at the rain layer already. This is just an instantaneous view. So you see a little rain here. There's a different layer called rain accumulation, which I find quite useful because this gives you a time range. Yeah, you can set the time range here, and it will color the map according to the total amount of precipitation forecasted for that time range. Yeah. Oh, sorry, I zoomed out a little bit too quickly. Let's go back. So what that here says, from tomorrow 9 to Monday, Monday midnight-ish, in the Maribor region, we should have about sorry, that's Ljubljana, almost nothing in the, sorry, the wind layer comes up quite easily. I need to move the location picker. So till Monday, we'll have about 1 millimeter of rain in the Maribor region. There's a little bit more around here, like 8 millimeters. But that's the total accumulation. That I find that interesting for ballooning because it gives me an indication how wet the ground is going to be and how muddy. Let's look at the time. We're 1910. We're through with the most important layers. Rain accumulation. Let's do uh, 3 more here. I'm not sure how familiar with the CAPE index you are. The CAPE index is basically an aggregate parameter indicating vertical lability of the atmosphere. If you will, a likelihood of thunderstorms. Yeah, it's a very good value to have for as a thunderstorm predictor. And so as we're approaching summer, late spring, of course, the sun has a strong impact on the thermal stability. And as we progress through the day, of course, the CAPE index is going to change. Sorry, I accidentally zoomed again. Let me run that for a day. Well, there isn't a whole lot in our region. Still, what we'll do, we'll focus on another region where the higher CAPE indices, like the Balearics and northeast of Spain. Let's go back to the morning. Let's look at, let me run it again. And for Palma, you'll see 12, 13, 2. So that looks like in the afternoon, the CAPE index rises quite significant. You find here the unit at the bottom. Green yellowish is about 1500. A value of 1500 is very strong, leaning towards thunderstorms, I would say. Anything above 1000 has high likelihood of thunderstorms. So that's the CAPE index for the thermal stability, vertical stability of the atmosphere. A very useful layer is the radar layer, which is called, I think, weather radar. Here we have it. This is a measurement. That's not a forecast value. Let's zoom in a little bit here. And we see still quite significant echoes in the Po Valley. That looks like a rest of a front here. again, we can run a timeline animation by moving and scrubbing here along the timeline. By default, this time interval is 1 hour, but you can set it to 6 or 12 hours, which gives you a longer look back, if you will. Let's focus on the last hour. So, and let's go back to our region where we played around. Okay, there's nothing going to be. So in terms of echoes in the weather radar, there's nothing going on. A very different affair would be this. That's in Upper Italy, near Vicenza or so. And you see there's heavy thunderstorm activity and lightning activity actually in this region. Windy has one interesting feature in the radar layer. Just to explain this, you see in the timeline a white section. The left section is white, and the right section is red. Everything in the white is an actual observation. So the center here gives you the last, that is the last measured radar image. Now, if you go move that timeline picker to the right, what Windy does is to forecast the movement of the cells in the radar layer in time. So it tries to guess where that echo layer moves within an hour. Yeah. So this is a forecast. This is not an observation. The last observation is from 1900 and 1910, and it assumes it moves easterly or east-northeast within that time. That can be quite helpful to estimate whether a particular thunderstorm cell will reach us or not, or by when. But don't be misled. This is just an extrapolation of the last image. What it does not show you is creation of new cells and decay of existing cells. So it doesn't take into account any new cells appearing. Still, I think it's useful to get an idea how fast that cell moves. So returning back to our example, Maribor, nothing to be reported here. Another observation view Windy is pretty good at is the satellite coverage. They've done a very nice job of integrating the satellite view. Let me zoom out a little bit. So, again, the timeline scrubbing is possible. Let me run that for an example. And you see the wandering of the satellite image. And actually we see that center activity in the southern Adriatic and over Greece in the Balkan. There are some choice methods here like blue, visible, or infrared. I have no idea. You need to ask somebody who actually has a clue about these things. I'm not one of them. But it's a quite useful, I find the combined view, the infrared view quite good because it gives you an indication where there's significant convective activity. There is a combination layer between weather radar and satellite film called Radar Plus. We have 12 minutes to go. That is the Radar Plus layer. You see, it combines the satellite background, the white haze here, with the echo. And again, we can have it animate in a timeline. It's still loading. So now it's running. So this is the combined view of weather radar and satellite films. Okay, that pretty much covers all the layers I wanted to cover. Excuse me. One thing I forgot was the wind layer, the altitude choice. You remember the altitude slider? That was that aircraft icon. I click it now, and you see I have surface winds now being displayed. By default, it's always surface. Let's choose a decent model like icon D2. Let's go back to Maribor. And now let's move the slider here. Now we're at 600 meters. You see? 14 kilometers, and at the ground, unfortunately, this location picker is a little bit fickle and tends to go away. But you see, as I scrub through the altitudes, the wind speeds and direction changes. So this gives us the wind values at high altitude. That only works for the wind layer. It doesn't work for the gust layer. Yeah. So, okay. That pretty much concludes the rundown of how I get this working. Let me return to the slide, and let me hop forward. We did the live examples. We're going now to the user-defined extensions, the plugins. Remember, that was only with the web interface. You cannot do this on the mobile layer over here. But I'm going to go through it, and you need to use a plugin. You need to install it, meaning you click a button within the Windy application to make it permanently available. There's no download or something to do here. It's all done through the hamburger menu. So we first need to install the plugin, and then we can use it. We'll go through these steps for 3 different plugins: the trajectory plugin for ballooning, the upper winds mostly for parachutists and balloonists, and pressure difference for alpine major wind systems. Okay, let me switch back to the map view. Okay, we're back in the map, in the browser view. So we're talking plugins now. I click the hamburger menu, and on the top right here, you find something called Install Windy Plugin. Yeah, and what it changes to a view where it lists a couple of plugins which are available for choice, and the ones which are available are marked as installed with a red text box here. So after trajectory, pressure difference, upper winds, those are well covered. And if they're marked as installed, if we go back to this hamburger view, you find that the plugins are listed here in the top section: pressure difference, flight planner, upper winds, density altitude, and trajectory. Okay. So to choose the trajectory plugin, we need first install it. We already did that. And then I click on the name of that plugin. That activates the plugin. Yeah, I can close the hamburger menu now, and you see we get a new menu which is specific to that particular plugin. A couple of buttons here to configure it. There's a menu button, and the tractor plugin allows it to choose the altitudes which it would predict the wind the tractor is for, and also the models. You can do one or several in one go. For sake of simplicity, I'll do just one model. The third parameter which we need is the duration of the forecast, or the expected duration of the flight. I've selected it here to be for 2 hours, but it can go up to more than a week. And that's mostly for the gas balloon competitions, which need a longer forecast duration. So we selected the altitudes. 3,000 is already a bit high for summer. We can click that away. I'm done with the choices. Now, what do I need? I selected the model, I selected the levels. What I do need is I need to select a location, the takeoff location, and a takeoff time. So let's assume we'll take off tomorrow at 6 o'clock. That would, I would press the start button here, and that would give us the trajectory for 2 hours. You see? So what happened here is, unfortunately, the lines are not very good to see, but here you see the forecast. This highlights the trajectories actually. So we would, taking off from Miklos, we would fly in mostly southerly or southwesterly direction. Southerly at 2,000 meter altitude and 1,500 and anywhere in between. Yeah, somewhere also is the ground trajectory. So that is the path which we would follow the ground wind. So that's just a couple of kilometers. So that's the forecast for that time, that location, the altitudes which we chose, and the duration which we chose. That enables just a view on the overlay here. What you can do is you can download these trajectories as GPX file or as KML file and use it in a different application. What I tend to do, we have 4 minutes to go, I got to hurry up. I use a site called GPS Visualizer, and that takes a file, date modified. I take the GPX file, and so draw me a map of this. Yeah. I'll go into full screen mode. This gives us a better comprehensible view of the trajectory forecast, independent of windy and whatever is on the windy screen. So it's a more permanent display. That results in a GPS in a URL, which is online for a couple of days. So you can use that to actually distribute this, say, via WhatsApp. Like, for instance, you can paste that link into WhatsApp. Sorry, I have to warn somebody that I'm in a Zoom session. Yeah, doesn't matter. Anyway, so you can download the GPS and browse it, keep it for later reference. That was the trajectory plugin. I'm going to leave it there. I'll show you two more, and we might be able to do within 2 minutes. Okay, I'm done with the trajectory plugin. I close it here, and it disappears. The upper winds. Okay, what that gives you is a tabular view of the vertical wind profile. Okay, for the chosen location and the chosen model. Yeah, and you see as this changes, you can have it referenced by different interpolation densities and relative to ground or to sea level. For whoever is interested in vertical wind forecasts. And the last one is the pressure difference chart. It shows actually the pressure difference between two locations, and those locations are predefined for the Alps region. For you Slovenians, the pressure difference Maribor Trieste, that is the Buja indicator. More than, I think, 4 hectopascal difference means slight buoy, and more than 8 is strong buoy. So, and actually we saw some buoy in the region, and you see here in these graphs, there should be, I hope this is correct. This shows you the pressure difference over time according to different weather models. Now, you see there are several of these relations predefined. One is the Mistral from out of the Rhone Valley. Yeah. And it also gives you the average wind at that altitude. 31 kilometers, so there's slight Mistral. Let's look for myself the Graz-Linz is an important one for the winter for long distance flights. So there's basically not much going on. And Innsbruck, München for more westerly flights. So that gives you the föhn inclination, if you will, or the to look out when certain föhn situations will develop. Okay, it's 1931, so I'm within an hour of what I wanted to do. Let me go back to the slides. So we did the plugins. That's in the slides. You will get the slides in a separate link. Radio sound. Just maybe hop through that. So we covered a lot of material, and very likely, once you start using it yourself, questions arise. My suggestion is go to the Windy Community Forum and use its search function. Practically every question always has been asked and answered at least once. If you're interested in a related theme, I did about 1 hour session about how to plan a long distance flight in winter for Alps crossing, and it touches upon some of the themes here. In terms of interpreting vertical radio sound ascents and vertical forecasts, I actually do recommend this link, and once in a while I post something on my blog. Okay, that does it. The plugins which you found in the radio sound ascent data were done by us three, by Hedy, my cherished meteor mentor, Chris Retiev, a good friend from South Africa and myself. So we did that part. Other than that, we have nothing to do with Windy in any shape or form other than being user. Okay, so that about covers what I wanted to cover. Am I still around? Am I still around?
Yes, you are.
Yes, sir. Yes, sir, you are.
I lost the Zoom window, sorry. I'm lost in Zoom window.
You
Zoom
have any pictures?
Okay. Have it. I'm back. Anyway, I rattled down quite a bit of material. So if there's anything I can answer any questions about it, this would be about the time to do this. I'm probably issued quite some confusion. So go ahead and bug me about it now.
Michael, I thank you
Yeah.
in the name of our club for your competition lecture, as you experience and knowledge. You are always modest. Thank you again for your time.
Sure, you're welcome. Anybody else has a question?
Hi, Michael.
Hi, Van.
Have somebody some questions?
Yes, I have a question.
Yeah.
Regarding the Windy, is there any option or possibility to take a screenshot, snapshot of the picture that is presented with the data? Or do I have to make regular screenshots on my computer?
What would be the purpose of you doing that? Sharing the information or recording it for later? Or
Yeah,
yes,
more or less sharing
need,
the.
Yeah, we need the. We're working in this project, Michael. We need to archivate the some pictures, the some datas.
I see. Okay. Well, I do have a recommendation for that, which is so Wind is the wrong tool for that. But anyway, you can do two things. Okay, let me share the screen for a second, and let's go back to this. I hope I'll be. Jesus, I always lose these windows. Zoom meeting. No, this. Mute. I think I screwed it and managed to drop out of the meeting. Anyway, I'll give it a step in terms of sharing information. First, about Windy and history. Can I show? Do everybody hear me?
Yes.
I hear you.
Yes, we do.
Excellent. Okay. Let's have a look at the timeline. Let me share. How do I share this damn window? Share screen. This is it. Okay, we're sharing that window. Okay. I'm back for the example wind forecast view with icon D2. You remember we could scrub the timeline down here. Now I go to the left of the interval, and you see I can't go back. Yeah? Windy does not record history. That's the bad news. And of course, it can't go beyond its forecast interval. But for looking at historic data, Windy is basically unsuitable. Because it ages out the forecast values a couple of hours. You can go back a few hours. We have now 1939, and you can get back at 17 hours, so 2.5 hours. That's all. That's maybe one forecast run. So it's not very good at that. What you can do is basically a screenshot, like doing with the means of the operating system we have. That's on a macOS level, but it's not on a meteorological level. So it's not very good for that. Okay, that will be only the picture, the screenshot, and nothing else. You can do, you can record a screen video with a timeline running, but that's about it. So history viewing is not very good, okay? If you really need to do that for other reasons, I would recommend a different tool. It's a service which is still being developed. It's called OpenMeteor. It's done by a Swiss guy who used to work for MeteoBlue. And this one, other than Windy, which is a end user application, we played through that. That's what's called an API. So that's some programming interface. That's what other applications would use to get at the weather data. But the upside, so it's not very well usable directly, although this website lists several applications, and some of it actually can access historic data. There are examples in this on this website, weather API. Yeah, you can enter a location, time, and actually forecast models and ton of variables, and this will retrieve values of these variables also back into the past, yeah, other than Windy. Some of the variables go back even 80 years or so. It's quite amazing what that guy has done. So for historic data, that's what I would recommend. Windy is pretty much useless for historic weather data, yeah? The nice part with using this, although it's not an end-user application, the historic data is kept online, so you can look at it later. Yeah, it does not. This has forecasts and it has measurements. It namely station data, so wind, temperature, humidity, yada yada. It does not have satellite, and it does not have radar and radio sound. But you'll see something at a historical weather where you can drill down on weather variables. That's what I would recommend. Windy always had a problem with that. We discussed this with them. You'll find discussions about this on the community forum. Basically, they're saying we're not interested. Use a specialized service for that, because we're here and now and look into the future, and this is it. It's too much effort for us to keep the history data. So the answer to that is no, except for screenshots, but there are other sources which you can use. Yeah? And there are applications which actually use that, For instance, there's one which was done by Haiti, which is actually an application for parachute jumpers, and it does have a way to access historical wind data. Let's go 10 days back. Yeah, it fetches the weather. You see, even the view changes, and it's down here. It should actually show the wind table at the time. Yeah. So this is an end user application which uses the OpenMeteo API behind the scenes. Yeah. If you're coding inclined, you can actually take her work and build your own. Because it's online on GitHub. That is the application which you just saw. That is exactly the same. So this one is also open source. It doesn't have a license yet, but it is open source. And you can take that and build on it. And it uses this historic data API here. So that's what I would recommend. Maybe give me an idea what specific values you would be looking at.
A good example would be meter and stuff, and those more or less aeronautical informations. But also, yeah, radar images. But as you told me, there is no possibility to take them from the API to get them.
Yeah.
Yeah.
No. First, they don't have the data. Yeah. They don't keep it. Second, the API in Windy is really simple. It's just focused on the visual display of that information. I must say that the OpenMeteo, the breadth of variables and time spans that are available is unmatched. So OpenMeteo does not have meters and TAFs, and since this is mostly textual information, I don't think a weather app like or an API service is the right place to search for that. I'm frankly out of my depths in answering that question. I wouldn't know how to answer that, but I think it's safe to say that Windy doesn't provide you with the meta and TAF, historic metas and TAFs. For individual values, OpenMeteo, maybe there's some site which archives meters and TAFs, but I'm not aware of any. I'm sorry, I can't help you there.
But thank you very much for the provided sources. I'll take a look of them, and maybe they will be good enough for what I need. Thank you.
Excellent. Good. Anybody else?
Yeah. Hi. Thank you again for this presentation. I hope that you can hear me.
Yes.
You have had presented a very interesting feature with these green dots for different airports. I just wonder, is this only the current meters and being represented, or is there also an option to actually see a little bit in the future?
Let's take an example. You should see that view now. I've selected the airport. Let's look at Maribor for the Wolfgang Maribor. Okay. Let's look at this. This is, I wouldn't be able to tell you more than that. It gives a little bit of history of the last 4 or so meters. The stuff, well, that's pretty minimalistic, and it shows its own meteogram. I didn't cover a touch on the meteogram because that was the time is too short to drill that far down. So no, I don't think so. Yeah, and the NOTAMs, but that is all. If you're unsure about that, I really recommend you go to the Windy website, search for the keyword meta, and if nothing comes up, just ask them for the sources where they get that from and what the time span of availability is. I wouldn't know how to answer that because I'm just a user.
Already from the user perspective, it's very useful. The only better thing I can imagine is if you go from point A to point B, that you can actually see, on point B I will be, I don't know, in 2 hours, and the predicted status is like that. That's all, but this is already quite useful.
Well, you see down here in the meteogram, they kind of try to do that, yeah. We're now at you see the vertical timeline here, that's the time indicator for now. And it kind of gives it a wind temperature, clouds, and precipitation. So it gives you some basic forecast. So this is based on a forecast data Windy has. That's not an official aviation forecast, if you will. So from a legal perspective, that is a different story. Yeah, if that is a relevant factor for you. If it's just about weather information, that is pretty good already. But no, it's not a preview of a meta into the future. Yeah, that's there. More I don't know.
Thank you very much for explanation.
Sure.
Urban, the sum thing you have in the layer route planning.
No, yeah, absolutely, and also that's what the TAFs are for. For me, my case, I fly to France, and it's quite useful to maybe check some of the airports near the route in case that you are weathered out. So that's all. But no, this is absolutely cool. I didn't know about that usability, although that I use Windy from very beginnings for water sports, and yeah, this is definitely a new gadget for me.
Okay.
Excellent. Good. Anybody else chipping in? Say again?
Just one more thank you for your time.
Oh, sure.
And
you're welcome.
We see you soon.
All the best. See you in Italy.
Okay. No, I mean we see us summer.
Sure.
Yeah.
Good. All the best. Was a pleasure.
Okay.
Don't hesitate. Drop me an email or a WhatsApp. It's on the slides. I think you got the link to the slides, so you can get that information. And if it's something unclear, I'm happy to answer that. Good.
Thank you. Bye.
Bye.
Okay. All the best. Bye, guys. Have fun.
Thank you. Bye-bye.
Thank you very much.
Bye.
Thank you. Bye.